So now we are coming to our fourth speaker, Dr. Bhushan Chumun from Mauritius. And I would request Professor Ram Singh Verma from Rajasthan, Bharatpur, to introduce our learned speaker. Professor Ram Singh ji.
He has to unmute.
Unmute yourself. Unmute yourself.
ओम सच्चिदानंदेश्वराय नमो नमः। इस वेबिनार में जुड़े हुए सभी पुनीत दिव्य आत्माओं को मैं अभिवादन करता हूं, अभिनंदन करता हूं। वे ऋग्वेद के पहले मंडल के 164वें सूक्त में 24 मंत्र में अग्निहोत्र के लिए एक मंत्र है, गायत्रेण प्रथममीते अर्कमर्केण श्याम त्रष्टुवेन वाकम वाकेन वाकम दुपदा चतुष्पदाक्षरेण मिमते सप्तवान. It's a great pleasure for me to welcome all of you, and I'm highly obliged to Professor Dr. Ravi Prakash Yar for bestowing me this opportunity of joining the international seminar on Agnihotra organized under the umbrella of Maharishi Dayanand Saraswati Chair and in Maharishi Dayanand University, Rohtak. I also congratulate Dr. Aryaji for organizing this pious and significant seminar. I'm grateful for bestowing this opportunity, and I invite Dr. Bhushan Chumun from Mauritius. Dr. Bhushan Chumun is an environmental scientist in Mauritius who has been trained in the UK, London. He currently works for the National Environmental Laboratory, which is the sole environmental laboratory of the government of Mauritius. He holds a PhD in environmental science, having extensively worked on the dangers of pesticides and heavy metals, and MSc in Environmental Pollution Control UK, and a BSc in Agriculture. Dr. Bhushan Chumun is also the president of the youth wing of the Arya Samaj in Mauritius, and is also an elected managing committee member of the Arya Sabha Mauritius. An environmental scientist, he is fascinated with the environment and health benefits of Agnihotra, and he shows interest in explicitly deciding the science behind Agnihotra. His topic of presentation today is environmental pollution control through the science of Agnihotra. Agnihotra is a Vedic ritual and a short form of a yajna performed twice daily at sunrise and before sunset, where different offerings made up of several ingredients, including medicinal herbs, are offered in the sacred fire burnt in the presence of wood and clarified butter ghee. Several benefits are associated when Agnihotra is conducted. However, it is important to enumerate the various environmental benefits associated. The world is moving at such a pace that progress is being seen everywhere. However, the environment is being taken as a scapegoat. Large acres of forests are being cleared to make place for buildings. This is in turn is causing catastrophic effect on our climate, starting with land, water, air pollution, and the long run leading to the phenomenon of climate change. This study aims at looking the different ways in which Agnihotra through past experiments being able to reduce the level of toxic gases in air, increased soil fertility, decreasing microbial load. Bioremediation of heavy metals, reducing pesticide toxicity, and reducing water pollution. This study will be a novel approach towards tackling environmental pollution, where innovative technologies such as artificial intelligence will be coupled with the practice of Agnihotra to monitor environmental pollution in different medias. I cordially invite Dr. Bhushan Chuman to deliver his lecture. Most welcome, Dr. Saab.
Thank you, Ram Singh ji. And thank you, Professor Ravi Prakash ji, for providing this opportunity. And I hope you all can see my screen.
Yes,
You can see my presentation. So like has been mentioned, my presentation is about the environmental pollution control through the science of Agnihotra. And actually, I will try to stick to the time that has been given. I've been given 10 minutes, so it will be very brief, the presentation. And I won't go.
You can
details.
take more time also.
Okay, thank you, Professor. I won't go in much details because the previous speakers actually have been watching this conference from time to time in the last couple of days, and I must congratulate Professor Ji for doing this nice job, for bringing people from all across different countries of the world together, all Arya Samajis together, and giving them the opportunity to present their research. And I must say, I had chance to see a lot of presenters, a lot of scientists, a lot of researchers, and most people, they have presented what actually other people they have done, what has actually been mentioned in the literature. And some of the scientists, they have actually presented what actually they are doing, but it's actually on very small scale. My attempt today is actually to present to you what actually I plan to do, because all has been mentioned in the literature that Agnihotra can tackle this kind of pollutant, that kind of pollutant. But actually, we have to look at the bigger picture if we want to present Agnihotra as a tool to prevent and control environmental pollution. So, like many of the previous speakers, they have already mentioned, Agnihotra is a ritual which can be conducted twice a day, at sunrise and before sunset. And I will go straight away to the subject. We use a Hawan Kun to do Agnihotra. And the Hawan Kun is normally made up of brass, copper, and nowadays we can see Hawan Kuns made up of alloy. Alloy, they actually a mixture of more than one metal. And the temperature that actually occurs at the core of the Hawan Kun, it's 1200 degrees Celsius. And we all know that the process of burning combustion that occurs in the Hawan Kun is an exothermic process. It actually produces heat. And the elements that we use to perform the Hawan, the Agnihotra, is wood, like we say samidha, samagri, ghee, clarified butter. They all added together in the Hawan Kun. And this process, actually, the Agnihotra, is an almost perfect combustion process. That is, we have lesser carbon monoxide that is produced. Now, the process itself, we have wood in the presence of oxygen. It burns to produce carbon dioxide and water. And our friends that have studied science, they know that this is a perfect combustion process when carbon dioxide is produced and water is produced in terms of water vapor, fumes. And we have a very minute amount of carbon monoxide that is produced in Agnihotra. And like I said before, it is an almost perfect combustion process. So this minute amount of carbon monoxide that is produced, it will cause no harm to the being that is seated, that is performing the Agnihotra. And like previous speakers have mentioned, in the literature, we have many scientists, we have many researchers that have worked on this, the beneficial effects of Agnihotra, how it can combat environmental pollution. It has been seen that there is a reduction in microbial load and also a reduction in sulfur oxide levels. And also Agnihotra can help towards water purification. And also the Hawan, the Agnihotra ash, it is used to enhance the soil fertility. So we can see these are 4 main items. They have been mentioned in the literature. I'm only taking the peer-reviewed papers, all the papers that have been published. I'm not mentioning studies that are still ongoing, because we have to take only the peer-reviewed papers that have cited in all these peer-reviewed scientific journals. Now, the rationale of the study, why I want to do study. Like I said before, it has been proven through past research that Agnihotra may be used as a process to reduce and remediate environmental pollution. However, it is also important to investigate the use of Agnihotra on more important pollutants. I will mention a bit later what are the more important environmental pollution. And also we need to move up with science. We need to use technology that are available. And nowadays we have environmental research. I'm into environmental research day to day. It's my routine. We are using artificial intelligence coupled with all the equipment that we are using, all the techniques. Actually, artificial intelligence, AI, it is facilitating our work. So the thing that that could take a longer time, we're doing it straight away. So probably we should couple Agnihotra together with AI to be able to produce better results. So the methodology, what I intend to do here, we'll go straight away to the experimental design. Agnihotra will be conducted in 3 different places: an industrial zone, a stone crushing zone, and a highly chemical input agricultural field. I have taken my country as an example. These are 3 activities, they occur, and they are the main activities that actually pollute the environment. So Agnihotra will be conducted twice daily for a period of 90 days in these 3 different areas. Now, since these locations are quite big, an area of 100 meter times 100 meter will be earmarked. And in this area, we will take our samples. And further to this, the levels of pollutants will be monitored on a real-time basis. This is where AI comes in, the artificial intelligence. We will get real-time data. And we will monitor in all these 3 sites, the sites that I mentioned before, the industrial zone, the stone crushing plant, and also the highly chemical input agricultural site. For air quality, we will monitor the air quality. We will use a real-time sensor to monitor the particulate matter, the PM, different level, PM10, PM, we can go whatever level we want, PM5, PM10, VOCs, volatile organic compounds, nitrogen oxide, sulfur oxides. We'll monitor this in terms of air pollution, air monitoring. And also, since all these activities, they lead towards the production of dye, leachate, and other water pollutant, real-time sensors will be incorporated in the waterways, whether it is a river passing by near the site, or is it a lake or a sea. We will incorporate these in these waterways, but which actually occurs, all these industries, all the activities, they get a license to dump their wastewater in these waterways. They have to get it treated before dumping. So we will monitor this through our sensor that we will put in these waterways. And all these dyes, leachates, and these things, these wastewater, they actually contain a lot of water pollutants, different water pollutants, be it heavy metals, be it we have high levels of nitrate, high level of phosphate, the chemical oxygen demand is high. All these things we will monitor through the IoT sensors and the real-time monitoring device that we will put in the waterways. Also, in an earmark area, when we perform Agnihotra, the ash that comes out as a byproduct, we will incorporate it in the waterways to see whether there is any activity, any changes in terms of the water. The treated wastewater contains a certain amount of chemical, but we will see whether it diminishes the amount of chemicals in the water present. And like I said before, I've already spoken about artificial intelligence. AI will be incorporated, coupled together with whatever device we are using to monitor these pollutants. And AI will be used to do predictions and also for modeling purposes. And I've already mentioned what are the key pollutants will be evaluated, like in the industrial zone and also the agricultural area and the stone crushing area. We will have heavy metals. Pesticide will come from the agricultural area. Particulate matter will come both from the industrial zone and from the stone crushing area. And sulfur oxides and nitrous oxide also will come from the stone crushing plant and the industrial zone. So we will monitor these pollutants. And these pollutants that are mentioned on here, they are not the smaller type of pollutant that have been mentioned in the literature. So we are thinking big here, because if we want to present Agnihotra as a key factor, as a key mean to prevent and control environmental pollution, we should tackle these types of pollutants. And also, at the end of the day, the fertility index of the soil also will be evaluated. The microbial content of the soil will be assessed, and the soil will be also assessed in terms of organic matter content and nutrient of this, and the nutrient content of the soil also will be monitored. And in all these three areas, we will monitor the soil. So that's it, friends. Actually, the study has not been conducted yet. So, like I said before, what was in the previous literature, what has been mentioned from previous scientists, previous researchers, have taken these examples, these processes, whatever results have been generated, and I'm coming up with something, an experiment, which we will be able to tackle these pollutants. And if we tackle these pollutants through Agnihotra, then we will be able to present Agnihotra as a good example, as a good process, as a good tool to be able to prevent environmental pollution and also control environmental pollution. So thank you again, Professor G. Thank you for this opportunity that has been provided. And thank you for all the listeners, and thank you to all my Mauritian friends and supporters that are listening to me today. Thank you very much.
Thank you, Dr. Bhushan. You have presented the plans of your experimental design that you want to carry out in Mauritius, in industrial zone, in agricultural sphere and stone crushing areas. So that's a good thing. And I think in collaboration, we would carry out this research in Mauritius also, so that the people over there, they may be convinced about the effects of Agnihotra. So I thanks a lot.